Okay, this one actually is a second videos I make for relative velocity. So in this video actually I will discuss another 4 partial question about relative velocity, and I think all of the questions in this video is about the plane, means what is the bearing of the plane, what is the time taken for the plane, what is the bearing the plane must be still, or something like that. So yeah, it's everything about plane. So I hope whoever watched this video, you already watched the first one, so you have the basic idea how to draw the triangle, and then yeah, you have the basic idea on how to put the relative velocity and all that. Alright, so over here I just show you how to solve this kind of question, and I find out almost all the partial question about the plane is quite similar. They are almost the same, they just change the number. So yeah, let's have a look on the first one. So this one, he said a plane's flight is planned directly from point A to point B. A distance 450 km means I know from A to B is 450 km. The bearing of B from A is 30 degrees. So I think quite similar to the question in the first video. So first 30 degree, I roughly got some idea like this. Alright, let's say this is north. 30 degrees is roughly like this. Here is 30 degree. So he says the bearing B from A means angle will add A here. B from A is bearing is 30 degree. Alright, so over here of course I know the distance for AB is 450 km. Alright, this is some basic information. Alright, then a wind of 80 km per hour is blowing from east. So from east means this direction. From east what? Then this velocity of the wind is 80. Okay, km per hour. Alright. So given that the plane is travel with 320 km per hour in the steel A, I say in the steel A means what? When you see in the steel A mean this one actually relative velocity, which is velocity of the plane relative to wind. Alright, or relative to A. But because here I use wind rather than use A, so I have to make sure they have the same symbol. So I change the A to W because it's same meaning. You just imagine like in the steel wind, something like that. Alright, so I got some information which is velocity of the plane relative to wind, which is 320. Alright, so now when the question says a plane flight directly from A to B, right? So I know this one should be the resultant vector, velocity of the plane. So therefore I need to form a triangle. If this is a resultant vector, means another 2 vectors plus together, I must get the A to B, something like that. Alright, so I just randomly sketch out the triangle. Since wind is from east, so maybe I connect the wind here, velocity of the wind, and then I connect the this one should be, you see, A, it's something like relative velocity plus wind, got this one, this is resultant vector, right? Let's say this is AB, so this is AC plus CB. Okay, I hope you understand what is the meaning for resultant vector. This velocity of plane, we do not know, we have to find it out. Wind we know is 80, velocity of the plane relative to wind is 320. Alright, we got some information. This is 30 degree. This is north. Alright, over here we need to find some angle inside this triangle. So in order to find angle, normally I will draw the north line. For those I think is possible to get. So maybe I draw a north line over here. If this one is north and this one is north, they are parallel, right? So I know here should be 150 degree, because this internal angle both plus together is 180. So here is 30 degree. If here is 30 degree, this is from east, right? So here will be 90 degree. So total angle over here will be 120 degree, because 90 plus 30. So the total angle over here should be 120. Alright, I hope you get some idea. So, what's the first question over here? Find the bearing on which the plane must be still. Okay, when they say the plane must be still, this one means they want to find the angle from relative velocity, which is the plane relative to water, plane relative to wind. Alright, so they want to find the angle for this one. So you must find where is the direction for this one. Is this one, isn't it? So basically I need to find the bearing for this one. Mean if the arrow is here, the bearing should be here. If the angle face this direction, the angle should be from here. Alright, so over here means if I can get this angle, I can easily get the bearing easily. So I need to find this angle. I want to find this angle. I got the opposite speed, and then I got this angle at opposite speed. I know I can use sine rule. So this sine angle over opposite length will be 80, and then this one will be sine 120. Opposite speed will be 320. Of course, if you press the calculator, you can easily get the answer for this one. So yes, so I just make sure I calculate in degree, then I press sine 120 divided by 320 multiple 80. Alright, then I just shift sine, answer. Then I got the angle actually is 12.5. Alright, if this angle is 12.5, we want to find bearing, right? Because I said bearing always must from north and must rotate clockwise. So from north, rotate clockwise until it touch here will be 30 plus this one, correct or not? So bearing will just equals to 30 degree plus, plus 12.5. So it's 42.5, right? But bearing always 3 digits, so it's 042.5. Okay, so this is the bearing. The plane must be still. Okay, when you say must be still means you must understand the question asks for the bearing for this line, not the bearing of the plane. Alright, and not the bearing of the wind also. Alright, so it's the plane, it is the bearing for plane relative to wind. Alright, so always when you see the plane must set the course, or plane must be still, the angle the plane must be still, you know that you have to find the angle for the relative velocity. Alright, the second part, he asked for time taken to the flight from A to B. So you know you want to find time taken. It's very simple, right? Because we know that speed will equals to distance over time. So therefore time will equals to distance over speed. So I need to I already have the distance 450 km. Of course now I need to find what is the velocity for P. So therefore I will need to find this angle first. It's quite simple because I got this one. I want to find this one. I just use 180 minus these two. This is 12.5, right? So plus this one is 135. 12.5. Okay, 180 minus 120 and then minus 12.5. So I got this one is 47.5. Alright, this is degree. Alright, if I want to find the velocity for plane, means the resultant vector here, is simple. I just use the sine rule again. So with velocity of the plane over this line, right? Opposite angle is this one. So with sine 47.5 equals to, I can randomly choose either one. Let's say I choose this one. Okay, so will be 320 is this line. Opposite angle is this one over sine 120. Alright, then I can get velocity of plane easily. So I just press the calculator 320 divide by sine 120 and then multiple sine 47.5. Yeah, correct. So I got the velocity of the plane will be 272.43. Right, now I want to find the time taken. Do we say in hour or in minutes? It doesn't say anything, right? So I want to find the time. It's simple. I just use distance, which is 450 km. It's stated here, divided by the speed, 272.43. You must understand the answer you got here is in hour. So 450 divided by answer. So I got 1.65 hours. Right. Yeah, this kind of question I think is 6 to 8 mark. So it's not really hard. The only problem here is you must know how to draw the triangle correctly and make sure you put all the arrow correctly, and also make sure you understand which one is resultant vector and the basic sine rule and cos rule. Alright, and then basic knowledge about the bearing also. Let me move on to the second question. Yes. Okay. I have a second question over here. And then let me change another paper. Alright. For this one, it is almost the same. He said a plane whose speed in the steel A is 420. So I see the words steel A. I will say this one is velocity of the plane relative to the wind. Alright, because I see the word steel A, so I will write down the information I have. Velocity of the plane relative to the wind is 420. Okay, travel directly from A to B, a distance of 1000 km. Okay, so basically a plane still the same, travel A to B. Okay, is 1000 km. Okay, so I know distance for AB is 1000 km. This is distance, this is not velocity. Alright, and then the bearing of B from A is 120. So B from A is 120, so roughly I want to imagine what is 220. 220 is almost, it's almost here. So let's say this is north, 220 is 180, 220 is somewhere here. So bearing of B from A, this is B, this is A. Alright, and then obviously this is 1000 km. So the plane travel directly A to B, right? A to B. So arrow is like this. This is velocity of the plane. Alright, A to B. Alright, this is a resultant vector because we learned about the additional law. Alright, so additional law tells us that velocity of the plane equals to velocity of the plane relative to the water, relative to the wind, plus velocity of the wind. Alright, this is additional law. So this one, velocity of the P is a resultant vector. Alright, now if this is 220, I think I roughly can get some idea. Never mind, we solve the angle later. We draw out all the line first. And there's a wind of 80 km per hour from the east. So we got another information is velocity of the wind is 80 in the direction is from east. So it's this direction. So since this is resultant vector, so maybe I just like, how should I connect? Okay, maybe I just connect this way. So let me like change red color to make you understand better. So I call this one velocity of the wind. This is just 80. And then this is resultant vector, right? So I plus it out. So this one should be the velocity of the plane relative to the wind. Alright, so from here, since this one is like from east, right? So definitely here to here is 90 degree here. So this is 230, so means here is 40 degree. Alright, you must able to solve the bearing thing and get your angle. And then first, find the bearing on which the plane was still. So basically, when I say was still, mean you want to find the angle from the relative velocity, which is this line. So now actually in this direction, right? So I need to find this angle in order to really get the idea what's the angle, what's the bearing the plane was still. Alright, so now let me see, do I have enough information? I got this one, isn't it? 420. It's given over here. Alright, so can I use sine rule to get this one? I got this one. I can't straight away get this one. I'm going to call this one is the angle I want. I need to get alpha first because I got 80 over here. So I call it sine alpha over 80 equals to sine 40 over opposite is 420. Alright, so I can get alpha easily. I press sine 40 divided by 420 multiple 80. Alright, then shift sine answer. I will got 7 point something. I got 7.03. Okay, let me just double confirm. Alright, sine 40 multiple 420 divide 420, divide 420 multiple 80 and then shift sine answer. Alright, this angle is correct, just 7.03 degree. Alright, then I can got this one easily, just use 180 minus 7.03 minus 40. Alright, so this angle should be 132.97. Alright, when you got this angle actually is bigger than 90, I recommend you like draw the triangle again. Yeah, just make sure you got the right triangle because it's easier for you to get the bearing. So yes, I'm going to draw a right triangle. I mean that I will draw a correct triangle. Okay, this is 132. Alright, so basically we have something like this. Okay, this one should be like this. 132 more than 90 is something like this. And this is like this. Okay, this one should be our right triangle. This is, okay, this one should be 132.97. Yes, alright, this one is 40 degree. And this one over here is 7.03. Alright, and then we got the arrow, right? This is velocity. Sorry, the arrow is this direction. This velocity of the plane relative to the wind is 420. And this one over here, this is velocity of the wind is 80. And this is velocity of the plane, which is unknown. Alright, so actually you see how I actually change this triangle into this pattern because of this angle. Because the 130 I know is more than 90, right? So I randomly draw like this. Of course, if you use ruler, you can draw a nicer triangle. Alright, so since this one is the correct one, now I want to find the bearing. Since I got all the angle already, I need to find the bearing for this one. So my bearing is always start from north, isn't it? So since the arrow is facing here, the bearing should be from here. This is north. From north we clockwise until here, isn't it? So this is 90 degree. So we got a 90 degree, continue until here. So I know bearing is very simple. Bearing is just like the 90 plus 132, isn't it? It's just 90 degree plus 132.97. Oh my god, I should use 133, will be easy. So plus 90 degree. So basically we've got just write 223. Right, the bearing is just 223 because you got the idea, right? This is north, this is from east, right? So here is 90 degree. So from north, we straight away turn the bearing until we touch this line. So basically it's 90 plus 132.97. Right, you can get the bearing easily. Then the second part, find the time taken for the journey. Same thing, we need to find the relative velocity for no, we need to find the velocity of the plane. So over here you can use sine rule or cos rule. Okay, but I always love to use sine rule because it looks simple. Right, so sine rule, right, we got the opposite angle. So VP over opposite angle is sine 133. Okay, let me use 133. Equals to, just randomly take any angle. Maybe I take this one. Alright, it's 420 over sine 40. Because 420 is this line, right? Opposite angle is this one. So you just use the calculator. So 420 divided by sine 40 and then multiple sine 133. So basically you got the velocity of the plane is 477.87. Alright, km per hour. And then you want to find the time. Do we say in minutes or hour? No, right? So it's just easy. So time is just equals to the distance is 1000 over the speed 477.87. So I just use 1000 divided by the answer. I got 2.09 hour. Alright, I just write short form. But you never write short form in your exam. Right, you can find out it's actually quite similar with the question just now. But this case, because you need to redraw the triangle, actually you can have like multiple ways to draw a triangle. You not necessarily must follow my way of drawing it. For example, like case just now, this one, isn't it? Okay, I just explain, maybe you can use the other way to solve it. Okay, let's say the only information we have is we got B from A, the bearing is 230, right? So this one actually fixed already. Alright, this is bearing given. So if this is resultant vector, the plane flight from A to B, right? But just now I connect my wind here. Actually, I can connect my winds from here also. Then I make the resultant vector. Do you see this velocity of the wind? This is velocity of the plane relative to wind. This is velocity of plane. I still fulfill this condition. You say velocity of the plane will equals to plane relative to wind plus wind, isn't it? This is resultant vector. So plane relative to wind plus wind got the resultant vector. If you draw the triangle like this, you still will got the same answer with mine. Alright, so not necessarily must follow my way. Maybe you can find another way of drawing this. So you just need to really try it out, and then if you find a different answer, you can try to let me know in the comment, or you find me on the Facebook page. Right. Because of the time issue, I'm not going to discuss all the 4 questions. Maybe I just take another one more. To make sure you can actually really understand it. So, okay, let me take this one. Okay. So, for this question is I think it's 2011 past year question, paper 2-3, October, November, question 9. You can find the same question from your past year paper. Alright, so over here, of course, you just changed the word plane to aircraft, but it's the same thing. An aircraft whose speed in the still A. So speed in the still A, first information come into our mind will be this is aircraft relative to wind, because in the still A is 350. Alright. Then flight in the straight line from A to B. The distance of 480 km. Okay, so this is the distance for AB. Alright, there's a wind, so velocity of the wind is 50 km per hour, blowing from the north. So from the north, I roughly got the idea is something like this. Alright, the pilot set the course. Alright, this is the key word for this question. If you couldn't understand this one, you cannot solve this question also. When he says set a course of 130, then a lot of students start to struggling. This 120 is for velocity of plane or the plane relative to wind. When you just set the course, this one is the bearing for relative velocity. In this case, it's A relative to wind. So this is the bearing for this one. When you say set the course of, this one is same meaning with the angle was still in 130. Alright, it's the same meaning with the angle was still, S-T-T-E-R-E-D. Right, it's the same meaning, but then he just used another sentence to write this out, because trying to make it more complicated. So now I know the bearing for this one, so I'm trying to draw it out. 130 is from north. This is north, right? So 130 is roughly 180, right? So 130 is randomly like this, maybe. Alright, and in this bearing, right, so I know the direction should be this way. This is velocity of A relative to wind, and this is 350, and this one is 130 degree. Alright, and then I got wind in this direction. Of course, if I want to find my relative velocity, I can. I already got. If I want to find my resultant velocity, yes, so you have to know resultant velocity. So this bearing plus this arrow plus this arrow, we should got the resultant vector. So yes, so maybe I can connect here, and then I got like this also can, or I connect here, and then I just connect here. Alright, this is velocity of the wind. So okay, I use red color to draw the resultant vector. So my resultant vector is from here to here. Okay, this is just a sample, because maybe later we need to redraw it if you've got a different angle. Alright, so from here, okay, this one will be my resultant vector. This is obviously is velocity of the plane. Oh, in this case, we never use plane, we use aircraft, velocity of the aircraft. Alright, so over here, the first thing is calculate the time taken to flight from A to B. So basically this is A to B. Alright, and then this is north, right? So I can draw a 90 degree because I need some angle in this case. I couldn't get this angle because 130 and this angle is impossible to get. But then we know if this is north and this is north, they are parallel. Over here, I can say this is 130 because this is 50, isn't it? In the internal angle, this one plus this one equal 180. Alright, so I got the angle here, and then I got the wind also is 50. I know that I can get the velocity of the aircraft using cos rule. Because two sides and one angle in between, we can always use cos rule. Yeah, before that, I hope you still remember what is cos rule. Alright, cos rule is simple. It's just a square equals to b square plus c square minus 2bc cos a. Alright, and then of course you move the square to this side, becomes square root. Alright, so now I'm trying to get the velocity of the aircraft. So equals to, yes, so I'm going to do the cos rule here. Because two sides, right? This is 350 plus 50. So 350 square plus 50 square. Oops, why I write b? Plus 50 square minus 2 multiple 350. And then multiple 50. And then multiple cos, the angle in between, 130. Alright, if you still very blur what's happening, you can imagine 350 is B and 50 is C. Alright, the angle inside here is capital A. Then you can get the basic idea. Okay, this is A I want to find, isn't it? I just move the square to this side, square root. So B square, this is B, right? B square plus C square, this is C square, you see, 50 square minus 2BC, 2B multiple C. And cos A, yes, this is how we do the cos rule. And this one you already learned in extended math, so yeah, I hope you can get this one easily. So yeah, I can use calculator to do this one. 350 square plus 50 square minus 2 times 350 times 50 times cos 130. And then I square root my answer. I've got the velocity of the aircraft should be 384.05 km per hour. Alright, after that, you want to find time taken. Of course, we need to know the distance from A to B, which is 480 km. Okay, it's given. So, yes, so we want to find time equals to distance, 480 km, divided by speed, 384.05. So, 480 divided by my answer is, I will got time is 1.25 hour. Alright, you can change to hour to minute if you want, but in this case I don't think it's necessary. And then the second part, he asks you to calculate the bearing of B from A. In this case, they want to find the bearing of B from A. That means what is the angle here? If you got the angle here, you can find the total bearing, right? So now I need to find this angle. It's easy. We can use sine rule if you want. Alright, so I just use sine rule to make everything look simple. So, okay, sine angle, which is this angle I want to find, over the opposite length is 50. Equals to, I want to take this one maybe, sine 130, sine 130, over opposite length is velocity of the aircraft, which is here, 384.05. Then you get the angle easily. I just press the calculator, sine 130 divided by 384.05 multiple 50. Alright, then I shift sine answer. Yeah, I got my angle actually is 5.7. Yeah, maybe 5.7. 5.7 should be fine. Right, so here is 5.7. So the total bearing of A from of B from A mean you want to find this bearing, isn't it? Mean from north go until this line. So basically you know it's plus together, isn't it? So therefore the bearing is just equals to 130 plus this one. So it's 130 degree plus 5.7. So it's just 135.7. This is bearing. Alright, it's simple. You see bearing must always from north, right? So 130 you continue until here. Okay, why I never take here? Because it said B from A. When it said from A, the angle is at A here. Alright, unless you say A from B, then the angle will be here. Some more the bearing, we always see the arrow. If the line is like this, arrow is like this, yeah, we want to find the angle from here. Means from north until here, this is the angle we want to find. If the line, arrow is face this one, we want to find this north, right? We want to find the bearing, which is from here, go until here. This is the bearing we want to find. Alright, so the arrow is very important in this chapter. If you like draw the wrong arrow, for example, this one he said, actually he said, yeah, this drawing from north, right? If you didn't see the word from, then you draw a drawing to the north maybe, then you got the wrong direction for the wind. If this direction is wrong, your whole triangle will wrong. Okay, so it's so important when you read the question, you must read carefully, and you have to understand, yeah, what is the meaning for pilot set the course, and then yeah, what is the meaning for the angle was still. Alright, you must, what is the meaning for in the still A. Alright, all this you must understand in order to solve the reactive velocity question. Alright, so I'm going to end the video here, and then I will make another, which is last video about reactive velocity. On that video I will cover the intercept part, and then I also will cover some is like the vector column and reactive velocity, mean the join between the vector chapter and the reactive velocity chapter. Yeah, so I will show you in the third video, no need to worry. Alright, so I hope you at least learn something from my video. Alright, thanks for watching.